Today we're going to introduce low voltage disconnect, um, low voltage disconnect into our circuit, and we're going to add a relay to it so that we can save our battery bank. In case you have a battery bank and you don't want to draw more than necessary out of your battery bank so the bank can last, then you need to introduce a cutout or probably a disconnect. And it's very simple, just a simple circuit. You have the input and you have the output and you have the display. In our previous video, we introduced a switch as a remote switch to the relay. But today, we're going to introduce low voltage cutout as a remote switch to the relay switch. And I have kind of pre-wired the relay already, but I'll still explain that. So all that we do now is to connect our power to the positive of the cutout. So I take the positive in there to our positive battery, and the negative power also is being connected to the negative part. So now we have, you can see we have power in there. I don't know if you can see, so I think there's too much light outside here, so that is it, maybe that way. So we now have power in here. The buttons we have here is to program. So assume now we have 12.8 as power in our battery. If you press and hold, it blinks. Then you can set the parameters as to which of the voltage, when it draws to that voltage, it has to cut out power, output power to your load, just to save your battery. If you don't do that and your battery depletes itself more than 50%, then you are permanently damaging your battery, and therefore it cannot hold charge anymore. So let's continue. Now that we have power in here, we now have to power the output, connect the output to our load. This time we're using a DC motor. But before I do that, let me just turn my power off first and do the connection. So the positive side, the output, positive of the output goes to the positive of the load. Then it has to be positive of the load. Then all I want to do is make sure that this voltage circuit here controls power to the motor. So if my battery is too low, assuming I've set the parameters on this to cut off around 12 point, maybe 12.6, then the moment this detects that the battery is 12.6, it cut off power to the our load or to the motor, so we can save our battery. Therefore, I'm now going to program the parameters here and see if it can really cut off our motor. Let us now introduce a relay switch into the mix, combined with the low voltage disconnect, and see. So we've talked about relays in our previous video. So what we have to do is to connect pin 85. It has numbers, pin 85 and 86, 85, 86. So these two will be connected to our output of the disconnect switch. So I take pin 85 and connect it to the output of the cutout switch this way, and then I take of the relay pin 86 to the same output of the cutout switch, this time the negative side. It doesn't really matter if you switch these two, it doesn't matter, they are just to energize or give power to the relay. So here, the output here will have to tell the cutter out to give power to the load, and that is the essence of introducing the cut out. The relay here, probably the essence is we need a heavy gauge. Assuming our load is a heavy duty load, we will have to apply a heavy gauge to the load. Heavy gauge from here straight to your switch is not advisable. You're going to generate heat. And sorry, yes, so the switch cannot handle that heavy duty. Therefore, you need a relay that can handle that. In our case, this is a 40 amp relay. Now that we've connected, and that being said, um, we are left with two solid prongs here. One is pin 30 and one is pin 87. So pin 30 is where you have to put in your power source, and then out of 87 goes to your load. So let's connect that to our power source. So we connect this to our source, which is a positive one. This to our power source. Forgive me, I have problem with cable management. So we connected our power source, and the other end of the relay, which is 87, goes to your load. Goes to your load here. Then the output, sorry, the negative of your load will now be grounded or goes to your negative side of the power. So this is the ground. Yeah. So what we're checking. Now let's make a continuous contact and set our parameter to maybe 12.6 and see if it's going to cut out. Off, cuts off. So means that our cutoff disconnect relay is working, and our relay switch is also working. So now we have to integrate this into our system and see if our battery can be protected by this cutoff, which gives signal to my relay for the relay to. As you can see, it's now darker, a bit darker in the room, so I can show how it looks like. We have 12 volts in our battery, and there's this LED red light that comes on, indicating that power is going through. So at 12.8. Now there are two buttons down here. When the left one, if I press once, it tells me that I have 12.7. That is what it has been set to cut off. So I'm going to press again, 12.7. That's the cutoff point. So when I draw power or current from my battery and get to 12.7, the output will be cut off. And then when will it come back? The next button, which is to the right, when you press that one, it shows 1.0, and that indicates that at 12.7, when it cut off, you need one more volt in addition to 12.7. So your power is going to be restored at 12.8 so that they can come back. I want to take that again. This is 12.7, that's our cutoff. When it cuts off, it has to come on at 12.8. Why? Because we also manipulated the come up time to 1 volt. So 1 plus 12.7 making 12.8, and that is when it will come back. So this is how we set it. You press and hold the love button, it blinks, Then you can now press either the right or the left to set it up, down, or go up. So if I want to set a cutoff point to maybe 12.6, I'll just press 12.6, leave it for just about 3 seconds, and then it restores back. So now we have 12.8 volts, but when I press once 12.6, meaning that I've set it to 12.6. Then come to the right one, press and hold. So if I want to add more volts, I'll have to continue pressing. So that means I have 1.5 volts in addition to my 12.7 cutoff. So that now it will be 12.85. That is what it means. So let's see, let's just connect. I have a LED USB power in there. I just connect a power to it. It comes on, and then I have a 12 volts LED light to connect to that. Yeah. So I have a load now, but my voltage is 12.8 thereabout, and the parameter to cut off is 12.6. So this has to be on until the voltage drop to 12.6. Then it will cut supply to my LED light so that my battery can recharge. And when it gets to 12.85, then it will restore power back. So it's a simple connection. Just you get power in here and then power out there. So battery connection comes in here, and then your 12 volts output goes to your load. So it's just as pretty simple as ABC. I hope you can see clearly now.